Is that?
And you keep dying.
I know. Is it a simulation, a mod? What is it?
That's probably it's kind of explains the simulation that we're in.
Right.
Yeah.
Just a little bit.
Well, it was loading
but
my favorite set of pistols from that game. So that
Perfect dark, everybody.
double handing those triple shot per trigger squeeze. That's the way to win, man.
Yeah.
Now tell me, everybody, and in the comments as well, are we real? Oh, we have our first. Yeah, hold up. Are we real? Everybody, show your hands.
Yes.
We are real, or maybe we aren't,
or we just have really advanced.
We're very advanced AGI, which that begs to differ. Like, what is real, right? I think, and that goes to the title of this. Actually, it comes down to the math, right?
Floating points,
Absolutely.
man. Floating points.
Yeah.
When you think about equivalence, too, like you guys have heard the old Einsteinian thought experiment, right? The idea that if you were in an elevator that with no windows or like a big metal box, and you had that thing falling in orbit, you'd experience weightlessness. But also, if you spun it at a speed that simulated Earth level gravity, or had the elevator sitting on Earth, right, the same feel subjectively is what you would have. There's no difference in what you would feel, right? So you'd be in space being spun around and feeling gravity or gravity-like effect, or you could be on Earth standing in the elevator, right? And the effect is the same, like indistinguishably the same.
Andrew, you look like you just hit a brick wall listening to that.
I feel like I dissociated.
Yeah, the idea is that the subjective impression of gravity is the same whether or not you're having it simulated by inertia or you're actually standing on a planet.
Do you feel like
thanks.
One of the three kings?
So the idea being like if we're simulated, right, or if this is a simulation, but it's this high fidelity, there's no difference between the simulation and the real world.
I mean, what is a simulation? What is real anymore, anyways?
Well, I think we're all technically little pieces of meat in here, right? We're in there, perceiving.
Mm-hmm.
What work?
At least to the best we can tell, that's what's going on. So I mean, the outside world seems to be there, but that's our eyes telling our brains that.
I mean, this is a question for
maybe this is the simulation box right here.
Can you we'll probably jump into that a little bit, because life is like a bunch of equations. Can you teach this fabulous image of God right here, this fabulous image of God, integral calculus? Because I think that we are missing a little bit of piece, and we don't follow the math. We follow algorithms and everybody else, and we all become a follower. We don't listen. We don't actually read. We don't really review or revise or follow the actual language of equation that the universe has granted us, the actual language of the universe. So,
well, I mean, math is just a really advanced compression, right? Like technically, you can get an intuition for integral calculus from the continuous world as it's smoothed, right? Like you don't even necessarily have to know what the math is to get the idea that you're approximating a curve fit over a continuous series.
Yes, I'm real.
I don't think you're real, Andrew. It's because of the baldness. It's because me and Greg have hair and you don't.
Right? I decided to grow it out here.
That's where the psyop is. You grew it out on your chin instead of on your head. They drew you wrong. You're very welcome. I like the aspect of being one of the three kings.
Yep.
Because when it all comes down to it, we have to look at the world through the lens of scientific equation, mysticism and psychological evaluation, just like the mystics of old, the Zoroastrians, the Sufi mystics, Christian mystics going up to the early church and the medieval. I mean,
Did you guys ever play Chrono Trigger by any chance?
oh, Chrono Trigger is amazing.
That one I've not played. I'm a big fan of Final Fantasy VI, so
Mhm.
So
Well, if you're
Melchior,
you're-
Gaspar, and Balthazar, which one's which? Who's who in this room?
no, Dave, I talk, Andrew chats, you can't shut him up, and Greg educates, okay? I talk, Andrew just won't shut up, and Greg educates, okay?
precision, my friend, precision.
Oh, I learned a lot from your guys' last episode just watching to
Mm.
to come up with better ways to explain the the early papers in the series and the early theory.
Mm.
The clarifications aren't super obvious, but I think the clarifications would be better. Like I'm not going to consider telling people to start with paper 70 and then go back to 1.
Hmm.
Because 70
I mean-
is where it like sums up the big picture.
Yeah. I mean, that's the beauty of all your papers, and you can go find. Greg has a whole load of content that we're going to dive a little bit into today, but 71 pages of the what he calls the chronotopological theory, or is it even theory? Is it real?
Well, it's the idea is what if we founded a new discipline? What is for example physics, right? That's a discipline of science, right? So chronotopology fits into that picture, right? It's best summed up as the the study of possible futures.
And what is a possible future? The fact is like we're laid out in this space-time continuum, but what if there's more beyond space and time that we do not know? So why can't we ascertain to the fact that there are multitudes of different futures that are at hand here, but we don't know which one that we're attached to? You literally have all these different choices. Go on, Ezra.
How can you distinguish that from string theory too? That's a big question. I'm sure some people might be asking.
Chronotopology started with a thought experiment. The idea is this: what if the first primitive isn't
Be safe there.
like space or time or matter or quantum dynamics? What if really the thing that came first before all those other things emerged was causality, and then causality became inviolable in the sense that it has to maintain itself as internally consistent given what's happened before, right? So you can imagine the first event is just like a dot, right? But you can't make any sense of this event without a second event that it's related to, right? So you have to have two events that are somehow related in order to even make sense of the concept of an event.
So
Right?
three points creates a trend, right?
That's what I say all the time. Keep going.
2 points creates distinguishability, right? And as soon as you have distinguishability, it demands a lot of other things, right? Because if events keep happening, then distinguishability within the bounds of causal order requires that the rules that were followed when the first two events happened must remain consistent, or you've unwound causality and broken the universe. Nothing would again be distinguishable, right? So to preserve distinguishability using the primitive causal order gets you the rest of the theory, right? That was the whole derivation task. If you start with nothing but causal order, and then you start tracking what happens from time zero, what must emerge? What do you get if you just follow events and see what happens? And as it turns out, to make sense of that, the rest of physics and chemistry and biology and all of it just falls out if you just keep following that aggressively. You have to really
it's less linear and a lot more geometric. It's almost like what you're taught in school when it comes to geometry. It's just it's just a base factor, and then you stop. And in
Mhm.
reality, the world is multi-dimensional in every facet that you can even comprehend. Like
Right.
there's certain things that we can never fully understand, but if you follow the math and you follow the math correctly, you're going to find little strings of different aspects of this universe that we don't know.
Well, consider this. Consider this. What if Ludwig von Mises were a physicist, and he didn't begin with human action to study economics, but he began with, and then there was light, and studied whatever principle is the basis for the entire rest of it derived, right? If you start with this first core principle, what is the impact on every event that came to now? And when we look around and see what we see, can that explain it? And as it turns out, surprisingly, the answer is startling, right? It does just sort of fall out of that if you follow it the way that I followed it. And I was careful to document and be really strict on myself. Like, I've discarded this thing 3 to 4 different times before I got to the point where I could even write down version 1, right? And then version 1 was inadequate, and version 2 was inadequate, and somewhere between version 2 and 3, something snapped into view and I couldn't find any more holes to poke, so I published the final series. And that's where we're sitting right now. But the effort was largely a very strict insistence that if something cannot be described as forced by the last thing, then it doesn't get included in the theory, right? So everything that we look around and see in the world, all the equations we know that work, because we have a lot of working science. That's the really cool thing about science, is it actually does work in like 99.9% of the cases. There's just like edge stuff we get wrong. And then there's this whole ontology underlying it that's really broken, right? The folks who came up with the early days of quantum theory, right? Like what they called the boys' physics, back when those early pioneers of quantum were making their observations. They developed an attitude that was just shut up and calculate, stop trying to explain, right? Because they couldn't make sense of the weirdness. And that sort of turned into this deal, right? Where all of science became this empirical data gathering and calculation task, where if we just accrue enough information and do enough math, eventually the explanation will fall out. Well, as it turns out, no, that doesn't work. So a lot of this is sort of a corrective, because the unification task, like trying to make gravity show up at the quantum level, doesn't make sense, right? If you really look at how it works, right? They hunted for gravity at that level and found nothing. And the reason for that was not necessarily that the theory was incomplete, but that the way that we understood the story of gravity meant that it shouldn't show up there, or meant that it should show up there. And in reality, we were letting our story drive what we were looking at, rather than trying to come up with a better narrative, or to put everything inside of a box and try to force them all into the same frame, rather than to put everything on an open field and see how they all fit together like puzzle pieces, right? So general relativity and quantum mechanics totally make sense together. And if you don't start from the assumption that gravity is a force, right? Mm-hmm. If gravity is rather an artifact of causal bookkeeping, then then the fact that it doesn't show up at tiny scales to make corrections where the mechanism is designed to make corrections over all the global surface, the whole system sort of rephases around gravity, right? You don't see it at small scales because you don't need it at small scales. At small scales, everything that needs to balance so that the universe still maths and you have closure. There's no open-ended processes breaking causality that didn't happen before, that if they had been possible back in the day would have broken the whole chain of events that created the universe that we understand, right? Like, the universe cannot contradict itself, essentially. It's forbidden from doing so.
And that brings us to a question, right? Basic question, observational. What do you guys do? And then to place a philosophical idea onto that, an ontological aspect. What do you do? Can you explain that just through what the basis of what you actually do? Like, what do you do for a living? You can't, because we're all in the same boat here. The one thing that we all do is try to explore this world with our curiosity and figuring out what can I do more,
Right.
rather
Well,
than rather than falling into the trap of I do this for a living or I do that. We're much more
yeah,
than just what society has given us. We
yeah,
all have a job, but we have to pay bills. We have houses to pay for. We have or apartments. We have food to purchase. We have families that we have to provide for. That is significant in our purpose. That is one aspect of a purpose, but there's more to that purpose that even we do not necessarily know.
yep.
I guess I could describe myself kind of as a sphinx. I just kind of float around, learn things, and try to get by day to day. I don't know. I'm not a master at anything particular, but I know how to get myself in and out of situations.
Yeah. I
That's
guess I would describe myself as a fearless polymathiophile, or something like that. I love comprehending, and my goal in life has always been undergirded with whatever thing I'm trying to understand. Right, when I'm trying to learn something new, which is my passion, I engage in that by selecting what I do rather than choosing what I do based on what I know. I choose what I do based on what I want to learn. If that helps. But like, if you ask for my career path, that's why it looks like, I studied poetry in college, went to law school, got into being the front man for a band and a songwriter for a while. I left that, got into software, got into especially, like, I built software for state governments, for the chambers of their houses in Indiana. They have a voting system because I worked on that. And then I left that and went into entrepreneurship, and I left I'm leaving that behind now to go into a side passion I've had for years, which is research. But AI research is kind of like a wrong way to put it, even though that's what I'm doing technically. I'm more of someone who's trying to understand what it is that makes this so unique for people, not myself. Right, I'm one example of all of us. I'm very, very curious as to what makes the whole universe fit together in one place. And that's been a project that I didn't realize I was after for my whole life. But as it turns out,
we all go down a road. It's a long road. Sometimes we get off of the exit. We have to get off the exit at some point for a pit stop, and then we get right back on the highway, and we keep on going, and we're constantly driving towards our destination of where we belong. Like, what is our niche? It's like we're all the whole saying is a jack of all trades and a master of none. I think that explains all of humanity. We're jack of all trades and a master of none. Yeah, you might be a master in one aspect of the many different trades that you get yourself into, but we're all effectively training ourselves in different facets of our life while we're trying to search for that one thing that we want to try to master, and that's just life in general. So how do you master life? I don't think you can ever master life. But what you can do is
mastery is not a destination, though, is it? Right?
Exactly.
It's practice. It's a way of being.
Mm-hmm. So when we finally get to that destination, which we'll never get to that destination because it's always we're always going to divert off of another exit ramp, and then we're going to get back on and continue the journey. It's always a learning experience.
We are basically, as a set of individuals and as a civilization, basically at every scale, humans are constantly tearing themselves apart and rebuilding themselves.
Except for now, I don't think we're tearing ourselves apart. I think we've gotten so comfortable that now we're at the spot in our species our generalized species life, where we're so comfortable we're being split apart from basically being too comfortable, not
Well,
being explorative, not being imaginative, not embracing the quantum for what we don't necessarily know, but what we do know on the basis of the imagination, of the creativity, of actually understanding that it's just a river that's very endless, and we need to just jump in that river. We need to get on that boat, and we need to just go down the endless river, and we need to go fishing. That's pretty much all it is. It's
well, I mean, maybe, I guess. I mean, I can see that frame from a metaphorical standpoint mapping, right? But
yeah.
But I do think that there is a sort of a fundamental misunderstanding at the root of all of our choices as a civilization, that are causing problems that we don't see we're causing ourselves, right? Like, one of the things that led me to chronotopology was this little experiment I did with Q-tip, which is a quantum computing experimental library that you can use in Python. Anybody can use it, and all the chatbots are great at writing code in it. So if you're not a coder, you can still run experiments. And I did this little experiment, and there's something. So in quantum computing, the problem is this: you run a calculation, and it computes, and the computation destroys the stable qubits at on a continuous clip. So to stabilize a quantum computer, you have to constantly generate new qubits as it goes, and it's hard and expensive, and it doesn't work very well, right? Eventually the whole system gets into a runaway state and decoheres, and you have to start over again from scratch. And so I ran this thing called a Low-Schmidt echo experiment. And a Low-Schmidt echo is like, think of like when you're in a room that has a sound echo, right? And you can hear the echo, and you say like, echo, and you echo, right? You hear that? And the echo back doesn't sound exactly like you. It's a little distorted, right? So a Low-Schmidt echo is a one-way calculation that can be played backwards. And if you play that forwards and backwards on a quantum chip, you can measure decoherence based on the stability of the echo compared to the original signal, right? So the idea was this: what if the reason quantum computing is such a pain in the ass is because they're overclocking the process. They're clocking the process to death. Tight synchronization might be what's actually making decoherence a problem, because there's this little known issue in sort of quantum level activity where you're trying to synchronize systems, but you get a synchronization cascade where it becomes over synchronized, loses phase, and then loses coherence. So my theory was this: if we let sort of like a loosely coupled non-monotonic wall clock, like a local clock at each meaningful point at that scale, decide when a given qubit would trigger an act, or some process would fire right across the surface of the computational manifold, then you might get better coherence. So I ran that experiment in Q-tip. I unclocked a quantum computer and let it run based on when it wanted to fire, as opposed to when the global coordination system said that it was its turn to fire on the schedule, right? As it turns out, the decoherence we create by clocking those systems globally is massive. The graph of stability looks something like this. I can draw it for you all here. So here's no clock. That's coherence, or decoherence. It sort of decoheres a little bit and then it levels off, stabilizes. And this is with a clock. Decoheres rapidly. It fails the Low-Schmidt echo test. And I was like, what's going on here? Right? Well, why is this working this way? And I was originally into loop quantum gravity. Like, that was the Carlo Rovelli theory. If you've ever read The Order of Time, you can get a big dose of LQG, which is really fun, but also ultimately incomplete. The thing that it made clear was that time is not a global phenomenon. There's no single wall clock, right? that runs the universe. And this is an easy thing to see once you start thinking about it, because right now, you as an audience member are sitting here watching our streaming show at this time of day for wherever you are, and wherever we are at our time of day. We can see the live clock in the corner here at 27:58. And when I said 27:58, maybe the latency between your computer and my microphone was so much that it said something later on there before you heard it. Time already starts over a small distance, right? So
wait, we have 27 hours in the day now?
So think about this, and then think about the fact that there are shows being put on right now live that you could go over and watch right now, and audience members sitting over right now watching live. They could live next to you or on the other side of the planet. They are experiencing time as if it were a singular thing from their point of view too. Right? But we are not experiencing their version of time. They experience their reality separately. So time is massively parallel. There is no one thing happening right now. There are things happening in parallel in these, sort of partially ordered sets of reality, synchronized sets of reality across the world, and they happen in massive parallel. There isn't just one time. There are lots and lots of times, and each of them is subjective to the observer.
So wait, what are you telling me is, if we all experience time at once in a linear fashion, and we knew what each and every one of us were doing in that time, then it would all make sense in the linear version of the clock system.
There is no organization that's global that makes sense. That's the thing.
Everything that
I compress like a timeline of all the shows on streaming right now into one linear sequence where this happened and then that happened and that happened is one line.
In order to like make that prevalent, we would have to like have everybody get together and be on a sequence of a live all at the same time, and it would be a clusterfuck.
Right.
You can't do it. So we live in right. We actually function in the parallel while enforcing a linear aspect of time, because we don't actually have a full understanding of time. So we have to reflect it through a physical apparatus, say a clock. I mean, when in reality, it's all based up on the rhythm.
Well, I mean, and
my mind just blew up.
Let me take you one deeper. What if time is not a universe phenomenon, but rather an experiential phenomenon that we generate by essentially causing synchronization cascades through observational phenomena, by experiencing the world, by bringing this Mountain Dew can into the frame. I've now synchronized this Mountain Dew can to everybody who's watching this show and added it to the set of things in this particular frame of reference, right? Now here's a cell phone. Whoop. Oh, wow, that's amazing, right? All of these things are now synchronized. Did that happen because the world has linear time, or because I added it to my linear time?
I mean, it'd be an interesting case to see both points of view.
Right. So now imagine all this happening in parallel, right? In the moment now, all of these times, and consider the future. And this is where chronotopology gets interesting, right? Consider what might happen next. All of the possible futures that you could, based on where you're sitting, plausibly engage in with, or plausibly select rather, with the limits of causal order and what you're doing right now. Like, I'm not going to fly into the air, for example, because I don't have a jetpack on. But if I had a jetpack, I might. All of these things that we might do next, they are bounded. They are limited. There's a limited number we can distinguish. Right? I can come up with I can spend the energy to distinguish a few more. Like, here's a vape. Maybe I'll vape next. I complicated the picture, but what I didn't do is violate causality. Now, what I can't do is say, I'm going to not vape. Right? I can't unvape as I'm doing it. The two things are causally incompatible. So we've got futures that can happen and futures that can't. right? One in which I don't have vapor coming out of my mouth is destroyed by doing this, right? The possible future where that didn't happen died the second I inhaled.
And that's what they call divergence.
That means there's a limited set of possibilities that we can distinguish.
Yeah.
And if there's a limited set of possibilities we can distinguish in any moment, that means the universe has finite bandwidth. And that means there is not an infinity of possibilities you can access at any given moment. That assumption is the basis of modern physics, and that's the correction that chronotopology makes.
That's pretty interesting stuff, man.
Yeah. That's I was trying to bring back to the last episode because you guys covered a lot of this stuff.
Yeah.
Touch base on it.
Yeah. Well, we try to. I mean, it is a lot of stuff to try to understand.
Well, and I also wanted to touch on your particular recognition of the sort of painful sparsity of it, the very constrained imagination space that you have for visualizing what it is once you start with paper one, right? Like the hardest thing for me was coming with a way to see it, to actually understand it in a metaphorical sense. It was really hard to do with such a lean set of primitives, right? It took a really long time for something that simple to cohere into something I could explain as if it were substantial.
Well, I mean, when you are in a lean environment, that does make it very difficult to build muscle.
Yeah, absolutely.
Expanding everything out.
Yeah. But if you think of the whole thing as like a fan out from one concept, causal order up to whatever we have today, can you derive the rest of reality from that one idea? You just happen to be right at the very beginning where it's so lean that there isn't a lot to say about it yet.
It's pitching a foundation. Yeah.
Yeah. Well, it's pitching an axiomatic closure regime where by the time you get to the end, if you don't have reality as we see it, then it's a failed paradigm, right? It's a innovation, absolute no margin for error. You don't tweak some parameters, it succeeds or it fails. And that's something that science used to do that it's kind of afraid to do now. Nobody puts their ass on the line with a theory that can either be right or wrong in no other way.
Well, money's on the line. It's how the education system works nowadays, is that everyone's trying to, front for the most politically correct, mechanism to move forward without actually taking any risks.
We're afraid to because it's getting harder to understand things, right? It seems like the more information we have, the more impossible it is the more data we have, the more impossible it is to discern any meaningful information.
Yeah.
That's not an artifact of human frailty. That is a function of physics. Limited bandwidth forces that on us. Like if you play a guitar through a compressor pedal, through a distortion pedal, what it's doing is shoving more signal than the amplifier can handle into the stream.
Yeah.
That creamy distortion, right? Not because all of a sudden the guitar only has one awesome string that plays polyphonic chords, right? You're shoving too much signal into the amplifier too fast for it to play discrete notes. It's Fisher smoothing literally governs that process just like it governs everything else. And seeing that is really hard to do when you yourself are the compressor, and we like to think of ourselves as more than that.
Right. There's a term for it. I'm trying to remember, a bottleneck.
Yeah, exactly. Yeah.
And then,
interestingly, that bottleneck is what sort of forces us to have a conscious experience of reality. Because if it were unlimited, there'd be no reason for us to monitor possibility like it were a limited resource.
Right. I mean, yeah, that makes sense.
Yeah. So, possible futures, the world's #1 primitive commodity. Most people don't realize.
Well, our whole existence as a species has been, moving forward in that way. Is it expanding our possibilities? Or limited, bottlenecked by our potential in the moment.
Yeah, absolutely. Well, the universe has been telling that story forever.
Yeah, and I mean
life itself was a set of continuation geometric structures that insisted upon continuing, right? That persisted by their own efforts.
Yeah.
So, and that is just another example of how we have to economize our futures. And that forces dynamics too. Like the limitation is actually really powerful because there are only so many ways certain things can happen.
Yeah. And I wonder what's going on with Zach, but
Indeed.
I don't know.
Well, it seems
Maybe
like
he's got a bottleneck on his camera.
his band limit is overcompressed at the moment.
Right. So where do we go from here with the stuff you've been researching?
We could talk about the second paper if you guys want. If you feel like firing up the video, we could do something like you guys did last time.
Sure. Do you got a video available?
Here, let me send a link.
Okay.
All right. Posts. I gotta go way back. It's fun to have all this content, but it also makes searching it a little bit slower.
I can understand.
That was 17.6. We're close. There it is.
I mean, 71 pages, right? So that's a lot of stuff to go over.
71 posts. Each one comprises 7 to 8 pages per paper. And by the way, this article, the explainer article, is a separate piece of work. If you want to see the actual math, you got to click download on the paper. Oops, and I was in the wrong one.
Yeah, forgive me for some reason I was thinking I said pages. I'm at posts. It's a lot of content for sure.
Okay, here we go. About to send you this.
Here we go. Just a second. Let me put it up here, and we'll get on into it.
Yeah, for what it's worth, the first article covered things at a broader sweep, and this is going to start making some of the early concepts in that paper more coherent.
Right. This one right here, right?
Yeah.
This one makes it. Okay.
Paper 2, a spoken word guide. Link fluctuation. Structure and regime-specific coordination in continuation geometry. Part 1. What this paper is trying to explain. Paper 1 gave us geometry. Paper 2 asks a different question. Once a regime exists, how does its coordination structure actually behave? Not in a vague sense, not metaphorically, not by importing laws of nature as ready-made objects. It asks, when a continuation regime is stable, what is the characteristic structure of its internal coordination fluctuations? That is what this paper is about. It discovers a constant, not a mystical number, not a universal generator of reality, a regime-specific invariant, a number that tells you how continuation multiplicity behaves when a projected regime is stable. Part 2, the starting point. The paper begins with a causal set, a discrete causal structure, events related by precedence, no loops, no contradictions, no infinitely dense pile of indistinguishable happenings. Inside that causal structure it considers synchronized substructures, not arbitrary chunks, substructures whose elements are coordinated enough to count as a live local regime. The first thing the paper counts is links. Not all relations, just cover relations. The immediate coordination relations. The nearest neighbor causal skeleton. That is a subtle move because it says the relevant structure is not just that things are related, but how densely the regime is stitched together at its active surface. Part 3. The fluctuation law. Now the paper does something important. It does not just count links. It looks at how the number of possible synchronized substructures grows as the system gets larger. And it finds that the growth is logarithmic in a very particular way. This is the key object, a fluctuation law. What it tells you is that continuation multiplicity does not grow arbitrarily. It grows in a patterned way that can be described by an effective coordination density. That coordination density is what the paper names with the constant. This constant is not the structure itself. It is a measure of how compressed or coordinated the projected regime is. That distinction matters. The constant describes a live equilibrium. It does not create one. Part 4. The constant. Paper 2 finds a specific numerical value for the stable projected coordination density of the familiar 3 plus 1 dimensional regime. About 13.81. That is the famous number in this paper. But the paper is very careful. It says this value is not a universal primitive. It is regime-specific, projection-specific, closure-specific. That means the constant is invariant only inside a fixed live regime.
Okay, let's pause right
If the
here.
regime changes,
Sure.
the constant can change too.
I just wanted to real quick touch on the concept of closure because it's actually a lot more complicated than it sounds from the word, but not so complicated it can't be quickly explained. By closure, what we mean is given a set of causes, when do the set of consequent effects and those causes that follow it sort of terminate in terms of what we could call a synchronized series of events, right? So I can illustrate that plainly. What goes up must come down. Closure. The down part must happen, right? Because it went up, but not happening right now, just sort of sitting here in my hand. It's already closed. So closure essentially is, given a perturbation or an interference in the status quo of a situation. Like I'm doing this very loosely. In the status quo of a system, the current state, you perturb it, you measure the next state. That resting state where it's still stable after you're done measuring it has to come from somewhere, right? Like how is this always falling at the same rate, right? How is closure always accomplished? That kind of closure is the same thing as this kind of closure, right? My hands slap together, you hear a clap, and then eventually the sound dies out, right? And then we're back to an unperturbed state. The sequence of events between here and the vibration of all the air molecules that go into the microphone that shoot through the wire that vibrate your speakers, you hear that sound. that is the synchronized set for that string of events when we're talking about that observational frame at that grain for that particular set of events, right? That's closure. But essentially the idea is everything sort of comes back to an equilibrium eventually. There's momentum and inertia. There's no perpetual motion machine, right? The fact that everything that moves must eventually grind to a halt, for example, is another example of closure, right? So there's nothing in this universe that doesn't begin and end within a contained set. If you can describe it discretely, like if you can describe a set of events, it's got closure in it. That's the simple idea behind it. But I wanted to throw that out there because I didn't spend a lot of time explaining closure in any of the papers.
It's okay. No, I understand, man. It's a
Let me
contraction,
pause.
right? There's this equal and opposite reaction, is what you're saying. And
Well,
it
I'm
eventually
just saying
dissipates.
the equal and opposite reaction thing maybe within a set of or a sequence of events in which or that terminates in closure, right? But it's not necessarily an example of it so much as a consequence of it being required.
Hey, William, welcome back, man.
Universal mind. What?
Yeah, I mean, this
What'll blow your mind later is what'll blow your mind later is like, is there any difference between a universe and a mind?
Good question. Will you get back into it?
So the paper is not saying, here is the one number from which the universe is generated. It is saying, here is the characteristic coordination density of a closure-stable projected regime of this type. That is much cleaner and much more powerful. Part 5. Why the constant matters. What does this number actually measure? The paper gives several interpretations. It measures fluctuation structure. It measures effective coordination density. It measures the compressibility of continuation structure. That last phrase is especially important. A regime is not just there. It has a certain internal cost of coordination, a certain density of stitching, a certain way that multiplicity behaves under projection. The constant captures that. So when you say a regime is stable, you are not saying merely that it persists. You are saying that its continuation multiplicity and its closure enforcement have settled into a characteristic relationship. Paper 2 gives that relationship a number. Part 6. Why the number can never fit perfectly. Now comes one of the deepest moves in the paper. The stable coordination density is not an integer, but realized coordination is discrete. That means any actual realization of the regime must carry a residual mismatch. It can get close. It cannot land exactly. This is a very beautiful result.
Let's pause.
Because it means stable regimes are never perfectly at rest.
So the awesomeness of this, and the really neat thing here, I overheard uttered jokingly, I know, what kind of Catholic am I on the last episode. And if you want to know where the divine infinite might fit into any of this, it's in that residual, in the fact that the coordination constant, no matter where it lands, ends up as a transcendental number. There's no ever perfect closure, right? Closure happens. There's a little bit of mismatch. Continuation pressure persists because of that mismatch. The infinite and the infinite in a balance that's a lot like parity, but not really. More like a meta parity, because set theory doesn't even include odd and even mismatch as a set. Like there's no actual formal set for the concept of odd even mismatch. Right? You could picture that, and it's really easy and surprising. There's not a set for that, but there's a set of odds, there's a set of evens. There is not a set of numbers that include both evens or even an odd mismatch in an alternating way. Right? We just call those integers, but we never really highlight the fact that they go back and forth between even and odd. This imperfect match is what allows infinity to be a concept, even that we can fathom and experience every moment. Because it's what makes reality feel continuous infinitely. Does that make sense?
I mean, it does to a degree, yeah.
Yeah. Because like if you're discretizing the infinite and it ever perfectly closed, that would be the end of the universe.
Right. So there has to be a constant alteration there.
That mismatch is what puts pressure on the present to continue.
Yeah.
So anyway, that was all I wanted to point out.
All right.
There's a fundamental infinity hidden at the core structure of reality. That sounds a little bit divine to me.
It does.
There is always a remainder, a small, irreducible mismatch between the ideal projected equilibrium and the discrete realization. Paper 2 says that mismatch has to go somewhere. It is stored, not erased, not wished away. Stored. That stored mismatch becomes part of the regime's live structure. This is one of the first places where chronotopology openly refuses the fantasy of perfect fit. Even stable reality carries residual tension. Part 7. Forward pressure and closure pressure. Now the paper names the two sides of the balance. One side is forward continuation pressure, the tendency of the system to keep expanding continuation. The other side is closure enforcing suppression, the tendency of the regime to prevent unconstrained explosion and maintain admissibility. This is one of the most important pairs in the canon. Forward pressure wants more. Closure pressure says, only what remains admissible.
Say that again. I'm sorry.
I was just commenting to myself that I missed an edit in the transcript. Editing this thing's a pain. Can you imagine trying to take a text to caption thing through this stuff? I mean, like,
yeah.
Okay, what did it guess? Right, I missed a canon where it put a double N in there. The paper's
okay.
not talking about one side open-ended tubes with explosives in it. We're not talking about those kinds of cannons. So if you ever see two ends, that's not what I mean.
Oh, that's fine. I mean, that's the thing about watching it back is that you get to go and catch the things that you did miss. I mean, nobody's perfect, so all right, get back into it.
Neither here nor there.
Yeah.
And the paper makes a subtle point here. These two pressures do not operate in the same form. Forward continuation behaves multiplicatively. Closure behaves logarithmically. That means closure is not just negative continuation. It is the log dual of continuation pressure. That is a very strong structural claim. It means the regime is balancing not two mirror images, but two different kinds of dynamics. Growth on one side, logarithmic correction on the other. That is why equilibrium lands where it does. Part 8. Equilibrium in log space. Paper 2 then shows that stable regimes settle into equilibrium in logarithmic space. This is another crucial move. It means that what looks unstable in raw multiplicative terms can be perfectly stable once you look at the right variable. Not the size directly, the logarithm of the size. That is where the system balances. This is the paper's way of saying, stop looking at continuation as naive accumulation. Look at the geometry of its coordination burden. Once you do that, the constant becomes legible. The regime is not frozen. It is balanced. Balanced between multiplicative drive and logarithmic enforcement. Part 9. Plateau regimes. The paper then introduces the idea of plateau structure.
Say that again.
You don't know sign language?
Mhm.
Well, I didn't hear what you said because of the video.
Yeah. That's why you gotta watch, Andrew. Don't be mesmerized. So don't be mesmerized. You gotta watch us. I'm gonna stop right there.
In fairness, I did use the physics to tune the animation, so it is phase locking your brain.
That's because Greg. I mean, I know Greg wants to hypnotize people, but still, I mean,
No, it makes it more understandable.
Yeah,
human beings love to be in phase lock.
But with that, the idea surrounding equilibrium, because I mean, to pull from a philosophical approach, not just the math, not just the physics, it all comes together. This is one reason why you can say that particular belief structures, particular cultural phenomena, this is why ethics, while ethics culturally are subjective in how you try to prevail it, try to build upon it, this is why morality in itself is a divine and a natural construct, because we all end up coming together in some sort of balanced articulation of what is right and what is wrong. So something there is objective. So like that's where the balance is a need. This is where the constant keeps on being the driving force, and why we as individuals, we as clans, societies, cultures, customs, religious factions, etc., end up constructively coming together into one inkling of truth in each and every one of us, to some sort of fullness that we don't even have a clear conscious of. So like this is where the fullness of the truth in all of reality comes to pass when we understand balance is a necessity. There's a truth here, there's a truth there, but where is the full truth in all of it? Because somebody's wrong while simultaneously being right. And that's why we need to find that collective balance within society, culture, and just the world in general. That's what I wanted to say.
That's a great ad, and I can't wait till we get to the trail end of the sequence too, because a good theory of everything, as Laplace would tell you, right, if he were alive, would is not a theory of a lot. It covers all of it, right? If we've got a right theory of everything, then meaning should fall out of physics.
I mean, isn't the thing about persistence is that you draw from different points of view in order to, reinforce your perspective?
Yeah, we're limited observers locally at our current grain, and all we can know is the reality we inhabit, not the one that we imagine exists elsewhere, because that's just imagination, not experience, right? We're not seeing all of it happen. We just perceive in our minds the sort of concept of other things going on, but they're not part of our observational grain. So The fact that something means something to us specifically here right now, and that there's a right and wrong version of that meaning, doesn't mean that that meaning terminates here, that we've arrived at some kind of answer that we can keep forever and shove on everybody else, right? We've resolved it here in this moment in our group, and that's it. And that's enough, because locality is king, right? We can't really do anything meaningful outside of our observation grain.
I mean, if you want to adapt something like with the market, right? They're always talking about how they want to get closest server to the New York Stock Exchange, and they're competing for nanoseconds in order to get the edge over the competition in the market.
Right, but imagine this for a second. There's pretty good odds that somewhere there's like a toy store where somebody just set up a domino rally. There's nothing you and I, or any of us on this stream, can do right now to flick that over unless you're sitting there. Right? We can imagine it cascading. We can imagine flicking it over ourselves. We can't do it from here. We don't even know for a fact if it's happening right now. We don't know the color of the dominoes. We don't know any of that shit. Right? We can just imagine it. The fact that we can perceive that and adds richness to our version of reality right here, perceive an imagined concept, right, doesn't mean that we're perceiving the thing itself. And so meaning is local. It doesn't make it subjective. It doesn't make it subjective in the crit theory sort of fluffy pseudo-ontology sense of polylogism and those jerks, right? But it does mean
makes it subjective.
That meaning isn't something that you arrive at permanently. It's something.
It only makes it subjective only on the course that we perceive things through our own different lens, and so that's how we kind of work within that parameter. So we're only subjective in the aspect of how we take what is the constant and make it for our localized regional base.
Right.
But in reality,
we can experience some. You guys want to do a little experiment here for fun? Sure. Just so you can experience this mismatch in real time. You hear the word Greg, and I hear the word Greg, and you guys think of me. That's you, Greg, and I think of me, myself. That's me. That's two different.
I think of Greg
right here in that room, or right here in this room. Right, Greg to me means me. Greg to you guys means that guy, not yourselves.
Want me to crash this observational experiment and say, you say Greg, Andrew thinks you, but then I think of this. Yeah. I think of Greg McAvoy.
Oh, cool.
With whom is a retard. Sports.
We've got them all into this cluster now too.
I mean, I was going to say mimic, but I guess that kind of ruins it. But William was talking about earlier sacred geometry. That this kind of reminds me of the seeds of life.
There is a sacred geometry.
Great metaphors, right? Though you do have to be careful with the of geometry, even as a primitive. It's not really, right? Geometry is nonetheless kind of an observational frame artifact that comes from the projection we inhabit. If we change projections, geometry isn't necessarily fluent. It just happens to fall out when we're talking about the physical projection of this particular physical chart of the way we inhabit it. Right? The human brain may have limiting factors as well within what we can perceive and distinguish. Right? Dogs can smell way more things in the same place than we can. To a dog, continuation geometry has a lot more sense.
There is sacred measurement. I mean, this coincides with geometric idea and the measurements that come forth of it. I mean, this right here, the length of the arc should be 300 cubits. Its breadth 50 cubits, and its heights 30 cubits. Make a root for the arc and finish it to a cubit above, and sell the door of the ark and its side. Make it with lower, second, and third decks. For behold, I will bring a flood waters upon the earth to destroy all flesh, and you're going to be stuck in a cubit, in 3 cubits. What exactly is a cubit, actually, Greg? I've never understood what a cubit is.
There's a fun homonym in there. It sounds to me like you're talking about either quantum computing and or biblical floods. But
it could be biblical floods, or it could be biblically flooded by geometric absurdity.
we are illustrating this point beautifully about meaning and continuation, multiplicity, and locality. I love it. Anyway, we should keep playing.
All right, I'll get back into it.
Engage.
A plateau is not the end of dynamics. It is a regime where the continuation width is no longer meaningfully increasing. Inside such a plateau, the coordination constant remains stable. The fluctuation law holds. The mismatch residual may continue to accumulate. That last point matters, because a plateau can look perfectly stable from the outside while storing tension internally. So a plateau is not nothing happening. It is a closure-stable region in which visible growth has paused while hidden mismatch may still be building. That is a powerful idea, and it becomes very important later in the canon. Part 10. Promotion and lift. Eventually, the paper says, there are conditions under which the plateau can no longer hold. Headroom goes to 0. The effective privilege of local continuation is exhausted. Closure fails locally. Then the regime reorganizes. This is where lift enters. Not as a free upgrade, not as a metaphysical leap, as a lawful transition out of a closure-saturated plateau into a new regime with a new coordination structure. This is important because it means the constant is not eternal. It is the invariant of a regime. When the regime changes, the invariant can change.
So bear in mind here that the invariant doesn't change in 3+1D Minkowski space, which is a way of saying 4D dimensional reality like we experience it, right? Like we live in 3 dimensions plus time, right? Space has height, width, depth, and moments happen in a sequence that we feel as time. That's a 4D or 3+1D Minkowski in general terms, although the way that Minkowski maths it makes it really useful for this, which is why I mentioned it. But you would have to go to 4+1 in order to need to change the coordination constant, for example. This it has to do with stable new degrees of freedom in an sort of an event space. What becomes admissible when you can fly into the air because you're a bird, is different from what a human being can do. We start flapping our arms. We do not take off, right? Birds start flapping.
Unfortunately.
They go into the air, right? Yeah, elbow to middle, correct. Nice. We can't really, we even more dramatic, right? We can't flap those and get anywhere. I guess except to an insane asylum if we do it the wrong way.
I think the tip is, I think William said that he tipped us, which means I think he just went and became a subscriber on our Patreon, Legacy Right 89. So anybody that want to tip and join, you can go, you can send us a tip at PayPal right there at the link, or you can send us, you can go subscribe to us and become a shareholder. Welcome in.
Yep. That's awesome. Thank you. So the point I wanted to make here is that the lift in other fields of science might call this something different. This is studied as avalanche elsewhere. It doesn't mean what you think it might mean from the plain word avalanche, although an avalanche is an example of that kind of avalanche. The idea is there's only so much snow that can fall on a place before it has to reorganize altogether. You can keep stacking so far until you can't stack anymore, and then what has to happen? Avalanche, right? It could just be like a drop of water, one little drop of snow on this pile. All of a sudden it can hold no more snow, and that next snowflake means the whole thing has to slide down the hill to fit more snowflakes. Right.
So don't be a snowflake.
Well, no, I'm saying like that's an example of what we would call lift also, right? Like a stable plateau can continue to exist until it can no longer handle any more stuff happening without it reorganizing globally.
See, I kind of wish that what you just explained, that lift would have done exactly what you explained, but it allowed the global structures of societal demands of overregulation to kind of destroy its marketing model.
Yeah, well, it's there's lots of cool ways to put it too. I've been lately shorthanding at my own brain more like a global rephase. Like you get enough phase mismatch, and all of a sudden, no amount of local adjustment can make it so that the system still coheres. So the whole system has to rephase around the change.
Code has to recede.
Yeah.
So what you're saying is you had a reset. Some would say a great reset.
Well, it's never really a reset though, because there's always some residual.
Mm-hmm.
Anyway,
sometimes
I just wanted to bring up avalanches because they're a great visual example for this.
Sometimes you got to eat the bugs, but every now and again, there's the steak that you cooked just last night, and it's still juicy.
That's what makes the screen look all trippy like that, right?
No, that's the acid.
You can only eat so much shitting before you're shitting.
Andrew likes grasshoppers.
Crunchy.
They are kind of, actually. I've had a grasshopper sucker once. And you get to the end of the sucker. The sucker was actually pretty good. I was like 9. The one that I got was like mango or something.
I think grasshoppers are too pretty to eat, man. I like them intact and living.
Oh no, this was intact. It just wasn't living. Got to the end of the sucker, sort of like the end of the Tootsie Pop, except for it was a grasshopper, and then you hear that great crunch, and it wasn't the sucker. It was actually kind of cool, actually.
For the record, I've never eaten a grasshopper.
Yeah.
Loser.
Not on purpose, anyway.
Eats the bugs.
We've probably all eaten every kind of bug there is. It just comes in cereal and doesn't. As long as it falls below the test quantities, they don't have to list it as an ingredient.
I mean, I've gone out and survived like Les Stroud and ate some bugs.
Yep. There is an FDA rule that allows a certain amount of bug guts to be included in every can of this, for example.
What about coffee?
Oh yeah, that too.
It matters.
Yeah. It's about It's about keeping the parts per million legal, right? It's not about turning it to 0.
It matters. Well, let's dive back into this, fellas.
Cool.
All right.
Keeps the paper honest. It does not absolutize the current world. It characterizes it. Part 11. Dimensional dependence. Paper 2 is careful here as well. The familiar value belongs to a particular regime, a particular projection, a particular dimensional closure condition. Different regimes may have different coordination constants. That means the constant is not just a number for reality. It is a number for reality under this closure-stable projection. This is a crucial anti-mystification move, because it stops the reader from turning the result into numerology. The paper explicitly refuses that temptation. The constant is not the cause of the structure. It is the invariant description of how the structure behaves within a regime. Part 12. The discrete continuum bridge. The appendix compression is one of the cleanest parts of the paper. Discrete growth enforces integer coordination. Continuum description stabilizes in logarithmic space. Residual mismatch is unavoidable. The mismatch is stored. Closure enforcement keeps the regime live. This is the bridge. The world is not
Lightning
purely
bolts are an
discrete in
example of
one
this
naive
happening.
sense, and not purely continuum in another. The discrete realization and the logarithmic continuum description meet in the regime's fluctuation structure. That is where the constant lives. Part 13. Why this paper matters. Paper 2 does something subtle but foundational. It takes the geometry derived in paper 1 and asks what stable coordination looks like inside it. The answer is not arbitrary, not hand-waved, not vaguely statistical. It has a characteristic density, a fluctuation law, a residual mismatch, a stored tension, a plateau structure, a lawful lift condition. In other words, paper 2 turns geometry into live regime structure. It is where chronotopology begins to describe not just space-like organization, but the internal logic of stable worlds. Part 14. Final compression. A closure-stable regime has a characteristic projected coordination density. That density is not exact in any discrete realization. Its mismatch is unavoidable. Its mismatch is stored. Its stability is a balance between multiplicative continuation pressure and logarithmic closure enforcement. That is what the constant means. Not a magic number, a live equilibrium signature. Shortest compression. Stable worlds cannot fit themselves perfectly. Their mismatch is part of their stability. Hard compression. The constant does not generate the regime. It tells you how a stable regime breathes. Margin line. Reality does not rest at perfect fit. It persists by storing the difference.
There you go.
Yep. And that is that's just another little baby step towards seeing the whole picture, right? That actually zooms in on something that paper 1 did not have the space to zoom in on without making the rest of it kind of incoherent. So we're actually going to, so for the next 2 papers, really, we're going to stay in this world and sort of look at the specifics of the early initial conditions, like this sort of fluctuation constant, for example. You can think of it as sort of the lowest point in a given attractor basin, right? You fill the basin up from the side with water, or sand, or whatever. It slides down the side and fills up in the middle, right? The width of that basin,
that's why
that attractor basin, what this coordination constant sort of acts as the gravity for, although gravity is a poor way to approximate it.
and that's why you should like,
gravity sort of a
subscribe,
non-local
and ring
phenomenon.
that bell, everybody.
Yep, we got more, but this was a key piece. So what do you guys think so far? I'm curious.
What do you guys think? Why don't you come over and leave a comment and tell us your thoughts?
Yep.
With that, you know,
How
we're
about you,
definitely
Andrew?
unpacking something.
What do you think?
We're definitely unpacking something interesting here. I mean,
And it is okay to not know what you think yet. That's fine.
Yeah.
Like that happened to me for the first 3 months of trying to understand what I'd uncovered. It still happens to me a lot when I think about it, actually, if I'm being completely honest.
Yeah.
Like when you stumble across something like this, it's not an invention, it's a discovery, right? So you end up seeing this thing and having all these pieces, and you still got to take them apart and put them back together before you can really get what you're looking at.
Basically,
this all started because a computer program worked better than it should have.
Basically, we can sum up what all of this comes to par. We can sum it up just like this: a rich man is wise in his own eyes, but a poor man who has understanding will find him out.
Exactly. And we are all poor men when it comes to understanding the big picture.
Mm-hmm.
Big picture's a competition.
Discipline your son, and he will give you rest. So discipline your mind, and you will finally find rest. Probably not the fullness of that rest. That'll probably happen when you're dead. But you will finally be at ease within your mind as soon as you kind of discipline it into the regiment of what Greg has pretty much laid out for us. And we've only seen it. We've only heard or read, if you want to go read it, a taste, just a sliver.
Yep. By the time we're done, though, we will have crossed from this sort of weird, sort of quantum-y feeling strangeness of causal order with discrete events and continuation pressure and closure pressure. Right? These things feel really abstract right now. That's good, right? Because any foundational theory should feel like offensively tiny. Right? If we're really looking at underlying structure that falls underneath general relativity and gives it its reason, and falls underneath the quantum, gives it its reason, and falls underneath the classical and gives it its reason, right? Like the whys behind it come out when you can piece them all together relationally. Those
like
pieces, those pieces can't be. You can't see it all at once, right? You have to sort of get a feel as you go. And we're in the early phases of getting a feel, but by the time we get, by the time you get past paper 11 or so, you start looking at phenomena that feel really, really, really familiar. Just modifications of science discussions that everybody's already had before, just in a new frame that makes a lot more sense when you talk about them together all at once, right?
Let's reimagine the system.
Before this is done, you'll be able to talk about general relativity and the quantum as if they make sense together, which is really fun.
They don't.
They do.
It's still not gonna make. You're still not gonna make sense of it.
I'm
not saying they don't. I'm not saying that they actually don't. I'm just saying you're a human. We're all human beings, and not all of us are Greg and Andrew. Everybody. Some of us just our mind gets blown and.
If I'm doing my job right, then I've explained it so pretty much anybody can get the big picture. You just have to be willing to commit some attention and learn a few new things. But they're not things that I'm unwilling to explain in detail until they help actually crystallize understanding. So that's the other thing. If anybody wants to reach out to me and ask questions, I'm happy to engage.
And not only that, but we had a comment earlier asking about integral calculus. Just go to the Substack, go to Design Heretic, and you'll learn your math.
Day at a time, man.
Please do go there. I would love to have. You're really early if you're showing up there, right? Like the cool part about this isn't necessarily what it tells you or what you can learn in and of itself, although that is fun for people who love learning. People who love building things. There are some novel, amazing things that we just didn't know we could build because we couldn't frame reality this way. And I can't do that by myself and still do research. So, there are gems in there for people who want to build and create something that nobody thought possible. And I'm really glad that whoever's listening here is getting this message and hopefully is excited to see what they can figure out. Because there's so many amazing things that we could do that we just haven't done because we couldn't see how to make them make sense.
The bigger the army, the easier the goal.
Yeah. So, welcome to the project, guys. If you're in on this, you're in.
Yes, sir.
You're gonna be in it no matter what. You're a part of it. Well, actually, you're not. You're a lay observer. But if you'd like to be a part of it, then you will be using it to build. And I think that's the beautiful thing. So with that, everybody, I think we have outdid our we outdid our I'm having an Andrew moment at this moment. But we
Hey, that's
outdid
my job.
ourselves today. We outdid ourselves. We've gone beyond where we'd like to lay for the day.
So before we go, though, I do want to give people a fun visual. I'm pulling up, and you guys, anyone who wants to, can go check out my code pen. It's literally codepen.io/designheretic, and you can see some visual experiments that include things. Yeah, like this one's fun because you can actually see the fluctuation constant creating links.
That's cool.
Look at those colors.
Yeah.
And
as each one of those events comes in, whether or not it is synchronized to an existing cluster, whether or not any of those lines are now started over, because it really gets blurry after a while. But see how some of them get close and then they all start linking?
Mm-hmm.
Whether or not a line is drawn is based on that coordination constant. So, and this would be uncomputable if we just tried to do this without the constant limiting multiplicative growth and closure. This would be uncomputable otherwise. Leastwise in a code pen in pure HTML, which is the amusing part about this. So
it's hard to write things in HTML and just language by itself. So
yeah, well, that was the equation you'll learn about in paper 3 and 4. It's called for anybody who wants to get ahead of themselves, it's called the Benincasa-Daukirk laser action. And those 3 scientists discovered this thing in causal set theory. This constant actually plugs into, sort of falls out of the equation that they use to generate what they call action. It's really more bookkeeping than action, but it's the first place that I found this constant. So, and it's actually a modified ABBM equation for anybody who's curious. That's a 1990s invention to make electromagnetic behavior in high energy electromagnetics comprehensible with respect to how they randomly have bursts of sort of decohering activity. They figured out how to calm that in electromagnets with that equation. And as it turns out, the reason it works is because the coordination constant is what it is. And you can then take that equation and play with it in other contexts once you realize that that coordination constant doesn't specifically care about electromagnetics so much as it specifically cares about events.
Oh, that's cool.
So
it's pretty wild.
Lots and lots to learn, guys. I'm looking forward to what we do.
Right. I'm looking forward to it too. So,
Andrew, you have anything to add, rebut, comment, structuralize, rationalize?
I hope you all enjoyed the intro today. I'll try to maybe cut up some more of it for tomorrow, next week's episode.
We can do tomorrow. Fuck it. Let's just do tomorrow. Who wants an extra episode on Saturday night?
Let's do it.
Well, I can't do Saturday night, unfortunately.
Saturday day, then.
Saturday day. Depends on the day. What time?
No. It's a problem with locality, isn't it? So yeah. How about we just go live whenever all 3 of us can jump on? You guys set it and then let me know and I'll roll in.
Maybe that's how we need to do this. We just go live whenever we feel it's time to go live. Screw time.
It would be an appropriately chronotopological way to go about it, I feel like.
Mm-hmm. What's going to happen is we're going to start going live at like probably noon every
3 o'clock in the morning. I'm at work. I can do it.
Technically, we're live at 3 o'clock in the morning somewhere.
It is 3 o'clock in the morning somewhere. So,
hey,
but anyways,
other side of the world.
If you're joining on the other side of the world, or just waking up on the other side of the world, good morning, good night, guten tag, whatever. Shalom.
Ciao, au revoir.
This is a Spock was blessing you, by the way.
Yep.
So, but I think it's time for the Bitcoin.
All right.
Hey,
Cheers, guys. Thanks for coming.
bye guys.
Peace.
Bitcoin, baby.
Hey, yeah, this is Bitcoin. I'm back. The king of the rap shit. I'm back in this Bitcoin, baby. I'm back in this bitch. Flossing fast cars and rolling with my clique. The king of the rap shit, the real OG. Whack ass rappers got nothing on me. Bought another Lambo, 3 hoes inside it, 10 hoes in line, ready to ride it. It's Bitcoin, bitch. Keep the track bumping. Really on the plug. I got pies in the oven. 80 years old, and your baby mama fond of me. All she wanna do is smoke my broccoli. Private jets from Rome to Ibiza. Lisa, Jenny, Julie, and Maria. Every day I gotta give thanks. I got Bitcoins in the bank. Bitcoin, baby. I'm back in this bitch.
Bitcoin, baby.
I'm a bad motherfucker.
Bitcoin.